Okay, so this video is going to be on factoring quadratics with a prime leading coefficient. So what that means is down below you have the basic standard form of a quadratic, so ax squared plus bx plus c. And when we talk about this idea of a leading coefficient, the number that is paired with the x squared, so this number here will be prime. Um, so that's what we're going to be doing in this video. That first leading coefficient is going to be a prime number, so we're going to learn to factor. So let's just go back over factoring quadratics in general. So when you factor quadratics in general, just remember that it breaks down into a linear times another linear. And basically that's nice because what we know is that the x squared gets broken apart and shared, so you get an x and an x here. All right, so that's the beginning basis of what we've talked about in the past. All right, so let's get into some examples and talk about them. So here we go. All right, so for this first example, let's go ahead and get started. So getting started on this first example, what we have is 2x squared plus 13x plus 15. And the first thing you should always do, just to note up here, okay, you should be looking for a GCF. Like there's a possibility that you could make this have less of a multiplier. You could remove those multipliers out. You want to do that. So the first thing I'll do very quickly is I'll look for a GCF. So I'll look for, does 2, 13, and 15, do they have any common factors? And the answer is those numbers themselves do not have any common factors. Okay, you can't divide 2 and 13 and 15 by the same number. So the next thing I'll look for is, okay, if there's no GCF and I want to factor, I must recognize that this is a quadratic. This 2 right there gives it away. It's a quadratic. So if it's a quadratic, we know that, as discussed earlier, that quadratics factor into a linear times a linear. So I'm going to set this up. So that means this x squared gets broken apart into an x and an x. But now I'm not done this time because in the past maybe we just separated the x's, but now we have a 2 with that x squared. So what's nice about this though is that that number that is with the x squared, okay, is a 2, and 2 is prime. So what we have now is the only way to make 2 is doing 2 times 1. So 2x times 1x, okay, is 2x squared. So then from here, what we're going to do is we're now going to follow, okay, continuing on with what we did before. So this is where it starts. We will come back to these two numbers in a moment, okay, but we're going to go our route that we normally finish with. So what we're going to look at is the factors of 15, and the factors of 15 are 1 and 15, and they are 3 and 5, okay? So when I take a look at these, right, in the past, you were just looking at which one of these two, okay, added directly to make the middle term, right? Well, if you notice, okay, in this case, none of these just add to make the middle term. And in fact, that's not the way we can do it this time. So what we have to do this time now is we are actually going to have to involve this 2. And to have something be a multiple of 2 means you double it. So if I double, okay, one of these numbers and then add its partner to it, okay, double a number, add its partner to it, I then will need to make 13. So let's just go through this process really quick. All right, so if you double 15, doubling 15 makes 30. Adding 1 to it makes 31. That is not 13. So go the opposite way. So let's double the 1, which is a 2, and add 15 to it, and you get 17. Ooh, that was close because sometimes people might want to subtract this. But here, let's talk about that if I wanted to subtract it. Let's pretend if I did 15 minus that 2, right? Because it got doubled, so that 1 got doubled. 15 minus 2. Now, there's an issue with that because had I written 15 and a negative 2, okay, when you multiply 15 times negative 2, all right, you get negative 15. So looking back up here, you would have get right here, okay, when you take them and you subtract them, not a problem. But what you need to remember is that that 15, okay, was the original number, but this 2 here came from this 1. So this 1 is the number, all right, that we will place into our quadratic as a factor, because the numbers we're going to place over here in blue are still going to be one of these factors, okay? So that means, okay, that you have to use some of these factors. Well, you can only use to make a positive 15 two positives or two negatives. So you're not going to be able to switch that. So that one was close, so close. So let's keep going. So let's say if I double the 5, so doubling the 5 makes a 10, and 10 plus 3 makes a 5 or a 13, and that's what we want. So notice when we doubled the 5, so if we double the 5, we make 10, okay, and we add 3 to it, that makes our 13. So this method here, okay, is just another method for doing these problems, and this is honestly the method you're going to want to be able to learn to do very quickly as you move up in math. The other methods end up taking too much time, so that's why I'm sharing this method with you. There are other methods, but as you move up again in math, the other methods tend to take a little bit longer to do, and therefore you lose time. So this one, while it seems to take long at first, ends up going a little bit quicker in the end. Okay, so here we go. Now let's talk about how we got this. So we have to think about how we made 10, all right? And the way that we made 10 was doing 2 times 5. So that means we do 2 times our 5, okay? And then we also had to think about, well, the 3 was made. Well, we didn't have to do anything to it, so that one is where the 3 goes. Now, notice how I placed the numbers in here. So I have positive 3 and positive 5. So I'm still using the factors of 15 as they are, the differences, okay, of where I placed them. So how did I make 10? So you do need to know in that one video that I went over, how is it that quadratics are made, and they're made by doing distributive properties. So you're doing double distribution. So if you take a look at this, all right, we can go ahead and we can check our work after we do it. So if you want to check your work, feel free to check your work. But the thing I would do is I would take the 2x, multiply it by the 1x, which gets me 2x squared. It's the first term is made. Take the 2x, multiply it by one of the factors of 15, which is positive 10x. Take the 3, multiply it by the 1, you get positive 3x. That's an awful 3. Okay, you get positive 3x. And take the 3 times the 5, and you get positive 15. Combine my like terms. And again, this is where I talked about the idea of the middle term being a byproduct, okay, because it's going to be the combination of like terms through multiplication, and there you go. There we have it. That's how we know that we indeed, for a fact, actually factored our quadratic correctly. Now, you don't have to show that work. That work is just for you to make sure you did it right on a test. But for me, I'm just showing you for you now. All right, let's go on to another example. All right, another example. So another example in which you see our quadratic has a prime number. So 3 is a prime number, which means the only way to make 3 through multiplication using integers is by multiplying it by 1 and 3. Okay, so, I mean, you could use negative 1 and negative 3, but don't do that for factoring purposes. So, first things first, we look for GCF, 3, 10, 8, nothing. Good. So here we go. So setting up my linear pairs. So that's nice. So this can separate. So my x can separate. And if you want to separate with a number at the same time, that's what I'm going to do here this time. And the order that you write it doesn't matter. What you'll notice is that I'm a person who's gotten in the habit of writing the 3 first and the 1 second. You don't have to do that. You could write 1x then 3x. I'm just writing it as 3x. And then I will write it as x. So it separates. So there's my prime leading coefficient taken care of. Okay, so the next thing I'm going to take a look at is I'm going to look at the factors of, now not just positive 8, I'm going to look at negative 8. So negative 8. So the way that you can make negative 8 would be positive 1, negative 8, negative 1, positive 8. And the other numbers I have here are positive 2, negative 4. And I also have negative 2, positive 4. So there's all my ways for me to make positive 8. Now at this point, okay, like we did before what we did is we had to double one of them because this number was a 2, but in this case, we now have a 3, which means one of these terms to figure out how to make the middle term must be tripled and then another one added to it to make, then its partner added to it to make negative 10. So here's the deal, okay? If this is a negative, notice you have one negative, okay, and its partner is positive. So, all right, the deal with that one is if you have one negative, one positive, all right? So the number that you triple, okay, generally speaking, you're going to want it to be a number larger than negative 10. So these are kind of your tricks. So here are some tricks to kind of help you go along the way. So since this term is negative and this term is negative, that means the signs of the numbers in here, one of them must be positive and one of them must be negative. Now you can't just go writing positive, negative, okay? So what you're going to have to take a look at here is, all right, you're going to want inevitably this negative 10, all right? So you're going to want a number that you're going to add to a value that gets you negative 10, which means, all right, which means that this one over here is going to be the negative. Because why? Because this is the number that I'm going to triple, all right, and this is the number I'm going to add to it to bring it back to negative 10. So let's take a number and multiply it. So now, what's nice about this is that I can inevitably look at all these problems and think about this. So 3, let's triple negative 8. So if you triple negative 8, that becomes negative 24. And negative 24 and 1 does not make negative 10. All right? Okay, tripling positive 8 is not, there's no point to it, so I'm not going to do it. So tripling that, I'm not going to do it because that makes positive 24. All right, going on to the next one. Okay, so let's triple the negative 2, right? So let's triple the negative 2. So if I triple the negative 2, negative 2 tripled makes negative 6, but negative 6 plus 4. Now remember, I would have stopped right there because remember, you want a number that's going to be tripled that gets you beyond negative 10. So I would have stopped right there as soon as I said negative 6 and said this can't be the pair. So going up to 1 now, I notice I skipped 1 here, and I did that kind of on purpose, sorry. So if I triple negative 4, tripling negative 4 makes negative 12, and negative 12 and positive 2 make negative 10. So here are my pairs that I will fill in. So that negative is a 4, and that 3x gets a positive 2 of that. Now notice I'm putting them into different groups. Now why is that I'm doing that? Because multiplication happens in these problems when it's done through the distribution property. So that means this 3 will multiply that 4 and this 2 will multiply that 1. So my final answer here ends up being, okay, this 3x plus 2 times x minus 4, and then I'm done. This is now factored. Okay, on to the next example. Okay, next example, 5x squared plus 23x minus 10. Now, some cool little tricks to note that if this last term is negative, that means, okay, one of the factors must be positive and one of them must be negative. So here we go. So that's a cool little thing to notice. The other thing to notice here is that my leading coefficient is prime, and there are no GCFs between any of these numbers. So 5 and 10, yes, but the 23 goes and messes it all up. So here we go. We now have prime again. So the prime I do is 5x and x. Now you have to be careful because think that this is how they're all done. This is how they're just done for if the leading coefficient is prime. So we have 5x and x, okay? So that's how it starts. Remember that x squared gets separated into two linears, and then we move forward. So now we're going to take a look at the factors of negative 10. So the factors of negative 10 are 1 and negative 10. They're going to be negative 1, positive 10. It's going to be negative, I'll start off with the positive. I usually would start in that way. So we'll start off with a positive 2, negative 5, and then we'll do negative 2, and then we'll do positive 5 here. Okay, so there's all your factors to make negative 10. And what I have to do is somehow, some way, make a positive 23. So the goal here is to make a positive 23. So when I go through this problem, I'm going to have to triple a number and add its partner to it to make 23. So let's go ahead and do that, okay? So if I take 5, and I have to remember, I'm not tripling it, sorry. I'm taking this one of these partners here, and I'm going to multiply it by 5 and then add its partner to it. So that means, okay, what I have to think about here is, all right, you see this middle term. I'm going to help you guys out here with some shortcuts. If that middle term is positive, all right, that means the larger of the multiples, whatever one is the larger multiplication, is going to have to be a number that's above, okay, above 23, and then you'll subtract another number from it to bring it back to 23, okay? So that means out of multiplying by 5, okay, will be a larger multiple in this case, then so will the 1 with it. So for me, I know right now I can go through my process. So multiplying this by 5, multiplying negative 10 by 5 gets me negative, gets me negative 50. Well, I mean, I don't want that one, right? Negative 50 and positive 1 is no good. It's not going to help me. So I'm going to move on to the next group. That's not 23. So 5 times 10. So 5 times 10 is 50. But that doesn't help me either. So now I could switch over to the other numbers, but I don't really need to for the way that I wrote these, so I don't have to worry about that, okay? So there's that. That's 50, and minus 1 is 49. That doesn't work. Okay, so now I go 5 times, let's say we did 5 times 2. All right, so 5 times 2 gets you 10, and 10 and negative 5 makes, well, negative 5. Well, let's switch that, right? So let's switch that order. So as opposed to multiplying the 2 by 5, all right, let's go ahead and multiply the negative 5 by 5. And when you multiply negative 5 by 5, you get negative 25. And negative 25 plus 2 makes negative 23. Ah, so close. The difference is that it was a positive 23. So the nice thing is, look down below, the last group here. So if you take 5 times 5, and why am I doing 5 times 5? Again, comes from this prime number over here, that 5. So 5 times 5 makes 25, and 25 minus the 2 makes 23. So for my answer, the numbers that I write along in my linear pair are the 5, positive 5, and the negative 2. So here we go. I will write positive 5, and then I will write negative 2. And if you notice here, 5 times 5 makes 25, and negative 2 times 1 makes negative 2x. So we'll put an x there. And that's how you know you make your positive 23 when those two get combined. The other stuff will work out because you're using specific numbers to make the first and the last two numbers. All right, so my final answer to this problem, without all that stuff on it, is 5x minus 2 times x plus 5. All right, last example. Here we go. All right, so again, I have one more example. It says 7x squared minus 23x plus 6. So we start this off again. The first thing I note is that there's no GCF between all three of these numbers. The second thing I note is that this number in front is a prime number, which means it can only be multiplied by 7 and 1. So that's nice. So this becomes 7x, and this becomes x. And the next step we're now going to have to do is we go write the factors of 6, and the factors of 6 are going to be 6, and this is positive 6, so again, okay, a couple things we're going to note here. So I have 1 and 6, and I have 2 and 3. Now, I want to point something out to you. So we're going to go back over into the original problem, and you see how this middle term is negative. So in this problem, if that middle term is negative and this last term is positive, it means that you're going to use two negatives, okay, to multiply it together to make positive 6, and that way when they get added together, it's going to make negative 23, okay? So again, what I noticed is that the last term was positive and the middle term was negative, which means that both my factors will be negative. So that means these will both be minuses. Okay, so now from here, we're trying to make negative 23, which means I need to triple one of these factors in here, or not triple, I keep saying triple, I do apologize. You need to multiply one of these factors by 7, okay, and then add the other to it. So here we go. So if you multiply 6 by 7, there's not a chance on earth you're going to get to negative 23, okay? Now, the next thing to do is try multiplying the negative 1 by 7. So negative 1 times 7 is negative 7, and negative 7 and negative 6 make negative 13, not negative 23. First group done. So basically what I'm hoping is that this second group works. So here we go. Negative 2 times 7 is negative 14. So just showing some work here for you, what I'm doing in my head. So negative 14 minus 3 is going to be negative 17. That doesn't work because we're trying to make negative 23. So let's switch it the other way. Let's triple the negative 3. If you if you multiply the negative 3 by 7, Okay, so negative 3 times 7 is negative 21. So negative 21 minus 2 is negative 23. And there we go. So I've got it. I've got my order. You just need to remember that I took the 7 and multiplied the 3. So 3 goes over there because remember I'm separating them because when you do multiplication in binomial times a binomial, it's done through distributive property. So I place the negative 2 here and then I'm done. My final answer is 7x minus 2 times the quantity of x minus 3. And this is how you factor when a leading coefficient of a quadratic is prime. All right, so I hope that helps, and you'll get your work with this along the way. All right.